Okay, Assalamualaikum dan salam sejahtera. Okay, this video talk about second order system. Okay, so before that, before this, we talk about first order. Okay, so from first order, we can see the parameter can changes the speed of the response. Okay, but now we want to know what happen if the system is second order. Okay, so the idea for the second order, you must know this one, s power of 2. Okay, so s power of 2 show that this system is a second order system. Okay, this is a basic equation, basic transfer function for second order. Okay, s square plus as plus b. Okay, this is a general equation. Okay, so the idea ataupun kita kata dia punya input, okay, basically start input 1 over s. Okay, so in this case you can see there are two finite poles and no zero. Okay, consider this a numerator, denominator, and then this one is a numerator, no zeros, and then two finite pole. Okay, so and then we want next. Okay, kita nak tahu bagaimana dia punya respon. Okay, so saya rasa this one awak dah belajar lah pasal overdamp, underdamp kan. Okay, so basically in the nice textbook there are 4. Okay, kita 4 respon. Okay, overdamp, undamp, underdamp and critical damp. Okay, so kita dah ada general equation tadi. Okay, and then put R equal 1 over s, and then taking Laplace, kita follow dulu, kita dapatkan dia punya k ataupun a ataupun whatever coefficient, okay, by using partial fraction and then inverse Laplace. Okay, so now kita pergi yang case pertama. Okay, overdamp response. Okay, so for overdamp response, there are two here at this one, kita panggil real axis lah kan. Two real pole. Okay, so you can see here. Okay, so two real pole. Okay, S1 and S2. Okay, ni example system. Okay, 9 over S square plus 9S plus 9. Okay, so you akan dapat equation macam ni. And then after you taking inverse Laplace, and then you can get the equation for the overdamp response. Okay, something like this. And then that's why you can get the graph. Okay, overdamp. Okay, the next is a underdamp. Okay, so kita nak tengok macam mana dia punya pole. Okay, for underdamp, dia punya pole adalah okay, two complex at at the real axis and imaginary axis. Okay, so you can see here. Okay, so there are two pole here. Okay, and then this one is a simple system. Okay, so macam tadi, okay, kat sini 2s. Okay, yang kalau overdamp dia 9s. Itu contoh lah. Okay, so bagaimana dia punya graph dia. Okay, so you can okay, you akan dapat gaya macam ni. Okay, dia akan increase. Okay, and then sampai satu puncak, and then after that dia akan maksud dia akan damp. Okay, dia akan damp satu keadaan, and then dia akan go to the steady state. Okay, respond. Okay, so yang ni macam mana awak dapat? Okay, sama je. Okay, taking partial fraction and then inverse Laplace. Okay. Okay, number 3 is a undamp response. Okay, so undamp response. Okay, bagaimana dia punya keadaan pole? Okay, there are two imaginary axis. Okay, plus minus j omega 1. So here. Okay, this one we call as a undamp. Okay, so you can see the graph. Okay, so consistent undamp. Okay, so kalau tengok dia punya kat sini, dia tak ada s tu kan, dia je s square plus 9. Okay, So in this one, you akan dapat daripada partial fraction and then inverse Laplace. Okay. Last one is a critical term. Okay, critical term is a 2 at minus sigma 1 ataupun maksudnya kat sini pole dia ada 2 at axis. Okay, so maksud same kat sini. Okay, so for example dia punya sistem adalah this one. Okay, kalau you factorize this one, you akan dapat s equal 3. Okay, s equal minus 3. Okay, so same method using partial fraction and inverse Laplace. Okay, so you akan dapat equation equation of response, and then dia punya graph this one. Okay, dia akan damp, and then lepas tu dia akan maintain. Okay, okay, so this one is a summary. Okay, so you can see this one is over damp, and then this one is a critical damp. Okay, second one is critical damp, and then third one is a underdamped. Okay, and then fourth one is a undamped. Okay, so basically untuk kita punya study, kita just focus underdamped. Okay, so nanti kita akan tengok dia punya sistem. Basically this one idea adalah untuk make border diagram. Okay, frequency response. Okay, this one is a general second order system. Okay, so there are two quantities. Okay, for the second order you must know. Okay, first is a natural frequency omega n, and the second one is a damping ratio. Okay, this one is at the meaning of the natural frequency. So you can see here. Okay, the natural frequency of a second order system is at the frequency of oscillation of system without damping. Okay, so the important is this one. Okay, frequency of oscillation of the system without damping. Okay, so kena tahu beza omega n dengan omega. Okay, so okay, and then damping ratio. Okay, damping ratio equal exponential decay frequency divided by natural frequency, or 1 over 2 pi multiply natural period divided by exponential time constant. Okay, ni dia punya meaning. Okay. Okay, so you can see the Ogata to get more mechanical, macam mana daripada mechanical daripada top, and then dia dapatkan the second order system. Okay, so you can find out the Ogata textbook. Okay, so but in general, okay, the important thing is this one. Okay, GS equal B divided by S square plus AS plus B. Okay, and then kena replace this one. Okay, replace S ni by omega. Okay, omega n. That's why kita akan tukar, bukan kita akan jadikan. Okay, this one is a general. Nanti kita akan convert kepada frequency, natural frequency kan. Okay. Okay, this one is a without damping. Okay, so this one without damping maksudnya undamped. Okay, so GS equal B divided by S square plus B. Okay. Okay, by definition, the natural frequency, okay, this one is omega n. Salah pula apa dia punya term kat sini. Okay, this one omega n. Okay, it's the frequency of oscillation of the system. Since the pole of the system on the J omega n, J omega axis at plus minus J square root B. Okay, so this one daripada kat sini. Okay, so B. Okay, so maksudnya this one is omega n. So omega n, okay, square root of B. Same as a B equal omega n square. And then for damping ratio, you can find that A over 2 equal omega n. So you akan dapat A equal 2 lambda omega n. So gantikan A dalam this one, okay, 2 omega n lambda kat sini. Okay, so akan dapatlah jawapan this one. Okay, B is a omega n square. So just replace B, this one B, and then this one A. And then you akan dapat, okay, the general second order transfer function. Okay, this one is a final one. Okay, you must remember this one. Okay, sebab kita akan selalu banyak guna this one lah. Okay. Okay, tapi yang paling penting adalah yang bahagian bawah ni. Denominator. S square plus 2 lambda omega n S plus omega n square. Yang ini sangat penting. Yang kat atas ni dia, kalau dia tak dapat omega n square pun tak apa. Sebab kadang-kadang kita multiply dengan gain. Okay. So, yang penting kita akan consider this one. Okay, to find the pole. Okay, so kita pergi kepada first example. Okay, so this example, we need to find the damping ratio and omega n. Okay, so consider you have a GS equal 36 divided by S square plus 4.2S plus 36. Okay, so meaning that this one is, okay, you compare dengan standard bond. Okay, this one. Okay, compare this one, omega n square is 36 and then 2 lambda omega n equal 4.2. So from here, you can find omega n equals 6. Okay, sebab you tahu omega n square adalah 36 kan. Okay, and then dah dapat cari omega n, and then you just put omega n here. Okay, 2 multiply lambda, damping ratio. Okay, multiply dengan 6 and then equal 4.2. So and then lastly you use calculator and then you find out lambda equal 0.35. Okay. Okay, same for this one. Okay. This one dia nak cakap pasal lambda tu. Okay. So kita basically kita ada the general dia adalah ni 0. Okay, lambda between 0 to 1. Okay, so maksudnya kita nak tahu apa akan berlaku bila lambda tu 0, apa berlaku lambda between 0 to 1, apa yang akan berlaku bila lambda tu equal dengan 0, apa lambda tu berlaku bila dia greater than 1 ataupun equal to 1. Okay, so kita dah dapat, so for the general equation kita boleh cari dia punya pole. Okay, so S1 2, okay, equal minus lambda omega n plus minus omega n square root lambda square minus 1. Okay, so you akan dapat dia punya pole ni. Okay, so kalau tengok kat sini dia adalah satu real number, satu complex number kan. Macam tu lah, dia macam ni lah, maksudnya complex. Okay, so bila dapat macam ni, okay, this one is a underdamped. Okay, underdamped. Okay, underdamped dia punya lambda dia between 0 to 1. Okay, kalau undamped, dia punya lambda is a 0. Okay, so boleh nampak dia punya pole kat mana. Okay, kalau ketika damped, lambda equal 1. Okay, meaning that dia punya real pole are real. Two pole are real. Okay, and then lambda greater than 1, so what happened? Okay, this one is a overdamped. Okay, hopefully you can understand the concept of the second order system. Okay, so you have another example too. Okay, you need to find the lambda and then you need to categorizekan dia. Okay, sama ada dia overdamped, underdamped or undamped. Okay, so let's say kita pergi yang this one dulu. Okay, so macam mana dapat? Okay, just gantikan di dalam in term of general equation and then you need to find the lambda. Okay, so kalau lambda dia lebih kecil daripada 1, lebih besar daripada 1, so dia overdamped. Okay, sama juga dengan B. Okay, lambda equal 1, meaning that dia adalah critical damp. Okay, C lambda equal 0.894. Okay, so meaning that is a less than 1. Okay, so underdamped. Okay, so you can refer the note. Okay, previous note. Okay, so I think that's all for the second order. Okay, thank you.